So, welcome to another Microservices Meetup. Once again, we have a speaker from the community, which I totally like. Not always the famous first-tier speakers, but also somebody from Munich who wants to tell us something about OpenTracing. His name is Juraci. He will introduce himself. Enjoy the talk and enjoy the evening. Thank you.
My name is Juraci Paixão Kröhling. I'm a software engineer at Red Hat, and I work on the Hopper project. And so the topic for today is OpenTracing, and I'll start talking about tracing. So what is tracing? What is it good for? We'll discuss a little bit about the differences between traditional and distributed tracing, and how is it relevant for microservices, and then what is OpenTracing, and we should see some code and to understand how OpenTracing looks like in the real world. Before going through the demo, I'll talk a little bit about Hopper. So what is Hopper? Just a couple of slides. And what is Hopper APM and what is Jaeger? What is the relationship between those projects? We have a demo. I hope it works. And at the end we have a Q&A. So I was planning to run a whole OpenShift instance here with Kubernetes and so on, but I had some issues with the network here, so we're just gonna try and do on plain bare metal. So tracing. I think we all know, or we all did tracing before. So tracing is that piece of code that you add to your actual business code to understand what is going on, right? So that log printing with the timestamp, and then seeing how long it took for an algorithm to run, that is tracing, right? So the basic form, the most basic form of tracing is that. So just printing stuff out to a log file. You use tracing to understand what's going on in your code. So you might be debugging an issue, then you have to print, you print some things to the log, you print the input to your program, to your algorithm. And once you understand it, you might need to improve it. Perhaps you have a performance issue, then once you change your code, then you might use tracing again to measure the improvements. Right? So that's tracing. Now, traditionally, tracing is very simple. It might start just as printing stuff to a log file, but it might also be a server somewhere that receives some captured data from a proper tracing library, right? So things like New Relic, things like AppDynamics, and so on. Now, that worked quite well for quite some time, I'd say, because our context was quite simple. It was very strict. So we had one thread, one process, one request coming in, everything very synchronous, very simple, very plain. At most, we would go to a database and do some queries and return something to the client, right? That worked quite well, but now with a microservices architecture, that becomes a bit of a problem because one request does not tell us much. Right? So one request is only one small part of the big picture of the story. We might have, in this case here, we have 12 components or 12 spans in OpenTracing. Span was a span, but mainly 12 units of work. And in this example here, we have 4 different components, so 4 servers, so to speak. And those are all part of the same context. So it's one business transaction, it's one request coming in through this red box here on the left. And that makes a call to a remote server to get the account for that user, and then another service to get an item from the inventory. And then once an order is approved and it's accepted, then an asynchronous process starts here, and it just sends a message saying the order is confirmed, and 2 other processes see that message and do whatever they need to do. So this is what we need today for distributed tracing. Now, the problem is, each one of those services might be written in a different language, right? So microservices usually comes also with a polyglot architecture. So I might have one service in Go, one service in Node.js, one service in Java, and so on. So how do I make sure that data collected from one component is compatible with data collected from another component? I might need to use different libraries because the library I'm using for Java might not have the same, or might not have the version for JavaScript. Now that's the context for OpenTracing. So OpenTracing is a vendor-neutral open standard for distributed tracing. It's part of the Cloud Native Computing Foundation. So is Kubernetes, so is Prometheus. The main idea for OpenTracing is to standardize the semantics for distributed tracing. So its main role is to say, those are the terms that we are going to use. So it's a span context, what is a trace, what is a tracer, and that's the role for OpenTracing. It's mainly an API. There are also some framework integrations, but that's the main purpose is just that. So it's not mandating anything on the back end. It's mainly for your application, for your code as a business application, that you know how to collect data. I'm going to go into details on OpenTracing. Basically, so I mentioned that OpenTracing is an API, right? But so there are no implementations for OpenTracing. So there's no OpenTracing itself is not the project is not an implementation. The only implementation that we have there is the no-op tracer that does nothing. Right? And that means you can start today and embed OpenTracing as a library into a project, but without any implementation, and then decide on the implementation later. Known implementations for the backend are AppDash or Brave to send data to Zipkin, or HopLarryPM, IEGA, and Lightstep. So the basic building block for OpenTracing is the span. So a span is a unit of work. So the smallest thing that happens in our code, and a span itself might contain other spans. Right? So in this case here we have a span for a MySQL query. So it recorded at the starting time and the end time, and it gives us a duration. So we have here, we know that this span to 300 milliseconds. A span might contain logs, so log entries like in a log file, or it might also contain tags that you specify as part of your business application. So in this case here, this span is a MySQL span, a query span, and as tags we add the type of the service, the SQL query that was executed, and some other metadata that we might need. So a trace is a collection of spans. This is an example from IEGA. It is part of the demo that we're running in a few minutes, and it shows here a collection of spans. So usually those are rendered in a Y as a tree, right? But in fact, a span might have multiple parents for some specific cases. So it's more like a graph than a table. Now, the same data can be seen on HopLarryPM like this. So it is the same data, it's the same application, it's just been displayed by different applications. So might be easier or different in purpose. How to see the same information. Now, how that works. So it works by serializing the span context before going remote, and then deserializing the span context when you get a remote call. Right, so there's no secret, there's no magic. whenever you receive a request, you check to see if you have a trace ID. If you have a trace ID, then you specify that and you get a span context. If you don't have a span ID, it's a blank context. And then before going remote, before calling another microservice, before sending a JMS message or something like that, you add metadata to the message to the carrier. And the other side of the connection will try to find that information within the message and build a new context. Right? So there is no magic there. This is the code that injects information. So in this case here, we have the tracer. Could be a Hopper APM tracer or a Jaeger tracer, Lightspeed, Lightstep. And then we inject the context as a normal map, is a map of strings. And we use this adapter here to add the information to the message. The message here is represented by the order object. And then the message is sent. Now, the other side of the communication here is this one. So it consumes messages to that endpoint, and we parse the span context based on the request that we received. Right? So it's simple. Now, this code here is showing that we are doing a manual process of injecting and extracting, so serialization and deserialization. But in most cases, this would be done automatically by framework integrations. So there's some libraries which were contributed to OpenTracing that puts listeners to servlets, to HTTP, Apache HTTP client, and so on. And so that means this kind of code here you might not need in the actual, in your actual application. Now I'm talking, I'm mostly using Java as an example, but that's because that's what I know. But there are libraries for most of the languages as well. So for Go, for JavaScript, for Python, for Ruby. Yeah, so that's basically it for OpenTracing. So OpenTracing, that's the picture. So Hopper is an open source project. It's sponsored by Red Hat. It's a set of monitoring related components, and some of those components are used in OpenShift. Hopper APM is one of the components from Hopper. APM stands for Application Performance Management. Some months ago, we decided to refactor our core, our backend, and we found out that Uber has decided to open source their backend. And when comparing what they had with what we wanted to do, we saw a match. Right? So we decided to join the Jaeger project and port some of the features from Hopper APM into Jaeger. Jaeger, it's an open source project as well. It was open sourced a few weeks or months ago, not even a couple months. It's used by Uber internally, and they have like thousands of microservices which are being used, so they are being traced by Jaeger. Yeah, so their view on tracing or distributed tracing is mostly focused on DevOps. So they want to know what's going on, what went wrong in a single request, on a specific request. So it's very trace-based view. I planned for today to also demo Jaeger. So I will leave that for the end of the demo and see if we can get there in time. Basically, if you want to see Jaeger, it's on GitHub/Uber/Jaeger. There is a Docker image that you can run. So what I'm gonna show you is then Hopper APM. So two different views. Well, actually one, and the second one we'll try to make it right as well. I cannot guarantee. But yeah, so let's move on. And So let's take a look at the code as well, because it might be interesting to see the details, how it all fits together. So I started here. I have a script to generate random orders. So this is a microservice. So this is an application with 4 microservices. The microservices are written in Java using Vertex. So Vertex has an event bus, and on this case here I have a distributed event bus. So that means I have 4 processes, 1 for each microservice. They are failing for some reason. But so they don't know about each other. They just communicate via the event bus. So it's not purist microservices, but it works. Yeah. So gen orders. And while it creates some orders, we can see, yeah. So can you see the? Yeah, okay. So we have 4 sources and 1 common module. Basically, the requests they start with the order manager here, and so in Vertex, the application starts in a vertical, and we have here a post. So we say that whenever we receive a HTTP request via post to the /orders, then we use this handler. And that handler, this is the method which is called, the first thing we do is we extract the span context. At this point here, for this service, as this is the very first thing that is coming from the browser or from the client, this context here will be a new one, a brand new context. So empty, a new trace ID. And then we start a new span. On this span here, we say that this request is a post request to the /orders. And we give a business transaction name. This is anything we want, and we are just saying this is the endpoint for placing orders. And then the next step is to verify that the account exists, and note that we are sending the order and the span that we created previously. Right, so we are going to use this span as the parent for the next span. So this is the next span. So the next span is the get account span. So we want to measure how long it takes for a account to be retrieved from the data store. Now, we are not doing that on our own code. We are doing that on a remote service. So before going remote, we inject the context into the order. So I'm breaking the lines here to make it more readable here. And and then we send the message through the bus to this destination there. And we pass the order along with the message. So the order is that message. Once we receive an answer, we check the stock, and it does pretty much the same thing. So we get a new span, and then we inject the context before going remote, and we send the message to the remote destination. The remote destination is, so the first one is the account manager, right? So account manager is a separate application, separate process. Could have been running on a different machine. And we here, so yeah. So here we say that we are handling the message from this endpoint here. And the first thing we do is extract the context. So On the other side, on the staging part of this process, we injected the contracts, and here we extract. So we deserialize it, and we might even create new spans on this process. Now, how does it all look like on server? It's like this. So we have a request going on. So if we can improve a little bit. Yeah. So this is Hopper APM. On the dashboard, we can see the latest operations, and then we have distributed tracing. So here we have an overview of our services and on what happens, right? So this is the initial endpoint for the order manager post/orders, and it's telling us that for this endpoint, 4 services or 4 other components might receive this request, might be part of the same transaction. We can go dive into one specific example, like this one. So it's very similar to the image I had on the slides, only that it was generated some minutes ago. So again, this is the HTTP request coming in, the account. We get the account. So the black arrow here represents a remote call. So up to this point here, it's a local call to the order manager, and then we have the account manager service on the get account span, and the database call. Then once that finishes, we get an inventory call, also black arrow, and we do a query on the inventory. When everything works, we send a message, we broadcast an event, and this is then acted upon by 2 different services. They listen to that message, that event, and they do something on their own. So there's one service that writes some order log, it just writes orders, and the other one is the inventory manager that will write an update to the inventory. We have also a transactions view. So it looks prettier usually, but we have here. So for Hopper APM, there are some tags that you add to the span, which are special. One of them is transaction. Right? So remember that on the place order handler, we had the place order transaction tag. And Hopper APM uses that to aggregate data and to show you business insights. Right? So we have here a graph, and we can see we had an outage, or the script wasn't running during this time. And then here's some bars, which also usually look better. Yeah, so here we have a dashboard for this business transaction, for the place orders transaction. We might select some business data, like item ID, so that we know that we have, we sell, so we have 1/3 of the orders are for laptops, 1/3 are for books, 1/3 are for cars. And yeah, so if we expect something different, then we might consume this data from a script, from a system, and send that data to an alerting system, right? So that we get notified when something goes wrong. So when deployed on a system like an OpenShift, for instance, or a system where it exposes some special environment variables, we would be able to get the same kind of view, the same kind of data, but instead of a business view, we would see an operations view. So we would know all the transactions. We would see all the transactions for a specific service, and if we know if the version of that application is also on the trace data, we could compare versions. So that would be this view here. So this is the same application deployed on OpenShift, and we have two versions of the same application deployed there. And we can do a canary release, so we can have the same service, the same, like the account manager service, running on 2 different slots on 2 different versions, and then we can compare the 2 versions. And if a newer version is better than the old one, or at least not worse, we can increase the traffic to the new version and decrease the traffic to the old one. Right, so so canary release is nothing new, but using tracing information, you can get the kind of data that you need, the kind of base for your scripts to decide whether or not to accept a change. Right? So it might be something on Jenkins, it might be something on your Puppet or Chef or Ansible scripts. Yeah. So okay. We can also look into the specific trace. We can see also some. We can store failures. So in this case here, we had a failure, and we record it as a tag. So again, on the code, you can see that if we have an error, we just set the status code for the request itself, and then we set a tag on the span called fault, and then we add whatever the fault we had, and then we finish the span. And that can be seen then on the transactions as well, on the flows. So the important part here, what I'm trying to show you is not Hopper APM. So Hopper APM, as I mentioned, we joined the Jaeger project from Uber. So this view here might not receive that much attention in the future, but similar features will be hopefully added to the Jaeger project. So the take here is add tracing instrumentation to your code, to your business applications. Later you can decide which backend to use. It might be Jaeger, it might be Lightstep, it might be some other OpenTracing backend. But the decision to instrument your code belongs to the development time. So before deciding, you can just start using that. Yeah, so all of this is open source. This example here, it is on Hopper APM source repository. So github.com/hopper APM. Then under examples, Vertex, we have this example. There's an Ansible playbook there that you can run and get the whole environment set up, including OpenShift and so on. And yeah, you can also get a Jaeger deployment running with that script. And yeah, so more information on OpenTracing can be found on OpenTracing.io. Hopper is at hopper.org. Source code for Jaeger, as well as examples, and the client libraries can be found on /uber/Jaeger. And the Hopper team hangs out on IRC on Freenode at the Hopper channel. And yeah, so I guess you're open for questions. Yep. Oh, sorry.
So,
Yes.
yes. So actually, I don't understand how you like pass through the ID of a. So like you aggregate information of a transaction. Like if you have got a legacy Ruby whatever service, and you want to trace the times from Ruby there.
So there is a OpenTracing library for a rack application. So if you're Ruby,
No. Specifically, Ruby can be Informix DB, whatever. Actually, I was just wondering, it's like you aggregate information of different services, and how do you know that they belong to the same transaction?
Oh, right. So that's a serialization and deserialization of the contract. So if your application is not instrumented with OpenTracing code, be it at library level or your business code, then there is no way for OpenTracing to know, for any backend to know that that service belongs to a bigger transaction, right? So that transaction, that service that you have needs to parse the incoming message or the incoming request, and whenever it reports there to a server, to a tracing server, it says, I'm part of this transaction. And then the server builds an image like this.
So like a hash or something like that.
Yeah, right, exactly. So for HTTP requests, when it's carried by HTTP, there is a HTTP header. Most of the implementations have them. So for Jaeger, it's like Uber, Jaeger, ID, trace ID or something like that. For Hawk APM, it's Hawk APM, _ Hawk APM, and so on. So, but that's specific to the tracing.
Oh, thank you. Should access.
There was swag involved, I didn't know that.
Will it accept?
Well, so after I just read all of them, then you guys can check some. Sorry.
I have a question about the header. What exactly information can be set there? Is it only about tags or some special values as well?
Let me see if I can find this slide here with this. Right. So a span might have tags. So that's metadata that you have for that specific span. Like what is the type of span? So in this case here, it's a MySQL span. It's a query dimension database. But I might also store data which is later consumed by other services. Which so those are the baggage items. So I can attach data there, which is then serialized and sent to remote server or to the remote service. And then the remote service, when deserialized the span context, it gets this baggage item. Right. So is that what it?
Yeah.
Okay. But usually, what in your business code, in your business application, you would just store metadata about that routine that you have. Right. So this is my place order unit of work, and then we think that this is a query that I did to the database, or this is a downstream request that I did to another microservice, and so on. Each one of those its own spans, and all of them part of a bigger span.
So if I would have a weird idea to propagate some object through this tag, this would not be a good idea.
By a tag, no, because a tag is local, but you might add items as a baggage items. Baggage items are transported down the, so let's say that I set a baggage item here on the first order manager or the second one. So the third item, the account manager would see the baggage items from the second span. Right, so I might add, I don't know, some. Right. So the thing is, I personally don't see much. I mean, I would use other things to propagate that kind of information. But you could. I mean, you could. The thing is, there are some implementations that don't trace all the requests coming into the service. Like imagine a company like Uber, for instance. They have tons of HTTP requests coming in, and they don't want to store like traces for all of the requests. Right, so they have a sampling, so they take like 10% of the requests and see if their system is okay, because they want to know when the problems arrive. So you might not rely on that information downstream. Right, so your third serial might not have the baggage item.
Okay.
Is that? Yes, that's okay. So,
Thank you.
Talking about problems, do we have a demo about alerting and the escalation or special destination about the alerting?
so alerting is not part. So OpenTracing itself is nothing about backends. So I've shown a backend here, like over APM, mostly because it's needed for a demo, right? But OpenTracing itself does not dictate. Now, some monitoring solutions like Hopper APM has a Hopper alerts module, so you could plug like Hopper APM into Hopper alerts, and then you get data flowing in there, and then that other system knows when there's something wrong. So it might do some analysis, it might generate decisions and send an alert or not. But that's outside of the scope for OpenTracing.
Now I'm deciding the order of the swag distribution.
Do you have any example where it makes sense to have multiple parents for a span?
Yes, imagine a batch processing, right? So you have a business process, and in that case, we had a asynchronous message, right? We had sending something to the queue, where, I think here, so the last 4 lines. So we have an event called order confirmed, and that's sent to broadcast to the event bus. And whoever sent that message doesn't care about an answer, right? So it just fires and forget. And something else then takes that message and processes upon that. But there might be something there that batches the items, that batches the message. So it creates an item and puts it into a batch. And then a process later syncs that queue, right? So in that case, we have 2 parents. We have one, which is a syncer, and one which is the one that plugged the item on the queue in the first place. Now that's very specific, that's very, but it's there. So, and you got the rest.
I would be interested how Hawkula relates with Prometheus, especially because you said that it's used in OpenShift, and OpenShift is kind of a wrapper around Kubernetes. Like Kubernetes provides Prometheus metrics, and then this OpenShift Hawkula comes in, and do you have both, or are they alternatives of each other, or how is the relationship?
Well, so you are right in pretty much everything. It's confusing. I mean, so Hopper itself, there is a component called Hopper metrics, and that's the part that receives metrics from several systems. In case of OpenShift, there is a hipster endpoint on each node. So are you familiar with Kubernetes, right? Yes. Okay. So in Kubernetes, we have a daemon set which runs a single instance per node. And we have a hipster as a daemon set for each node that receives metrics for that host. And that sends to Hopper metrics. So that's how it's done for OpenShift. Now, Prometheus joining Cloud Native Computing Foundation is something relatively new, right? Because Kubernetes is the first project there and so on. But that just means that Hopper metrics is the one being used in OpenShift. I mean, yeah, there is Prometheus on CNCF, but it's not what we are using in OpenShift.
Yeah. Is there an API for accessing the metrics or the stats of the transactions, so you could include your particular part, for example, in your file is everywhere, and build an aggregated view or something, or you have only this interface provided by the partner itself?
Yes. So this is not in the context of OpenTracing. So OpenTracing is only the spec for the client. So it's how your application would report data. How would it collect data, right? So now each one of the backends that I know, they provide some way of you getting data out of it. Like Hopper APM, there is a REST endpoint, a REST service that you can query and get aggregated data. In the backend, Hopper APM uses Elasticsearch, so you could go directly to Elasticsearch and get your own information there. Jaeger uses Cassandra, so you can also go directly to Cassandra. And so, yeah, I think most of the concrete implementations provide some way of because nobody can foresee what you want to do with that data.
So, as far as I understand, you have a chain of services that call, so the call is propagated through each service. So if, for example, I have a legacy service that I cannot change, I cannot insert new code there, is there a way to wire up somehow the context through this service?
If you cannot change the application code, and assuming that it's in a language that you can instrument the code, then yes. Like in Java, you might need to add a Java agent to the command line. So Java means Java agent and so on. So there is a library on OpenTracing for Java agent. It's contributed from OpenAPM, and that means your application is completely agnostic from OpenTracing. And whenever it can, it will inject code, bytecode. It will listen to calls to your methods via bytecode injection. Right, so that's an approach that would also work. I don't see why not in PHP and for Ruby as well. But in languages like Go, that you compile, ahead of time, you don't actually have this possibility.
But you're using some kind of hash or some kind of unique ID, right, to trace this stuff?
Well, the ID is generated only at the beginning of the chain.
So if I have an access to this ID somehow in some service somewhere, so can I theoretically just wire it up? Or
I don't see the use case there. I mean, if you can't change your code, then you don't know about this ID already, right? But if you know that about that ID, then you should probably embed the OpenTracing library.
In one service, I cannot change the code, so I can skip this step. What's the next one?
Oh, I see. Okay. Again, using a instrumentation approach, an automatic instrumentation approach, it's possible. So for the Java, I'm using again the Java example. I don't know if that's your case, but I mean, that's what I'm more familiar with. In Java, with the Java agent, you could instrument the request coming in and the HTTP client going to the next service. Right. So you have a code here that listens to records that right. Now it's not that simple because if you are in asynchronous mode, then where do you store this information? How do you correlate the request coming in to the request going out? But that's, yeah, there's no magic.
You showed some example in your screenshots where you say you can also attach logs. How does it look like? Does it instrument your logging frameworks?
Yes, there is a library for OpenTracing that is a SLF4j, for instance, implementation. But might also work with other languages that it's a OpenTracing implementation of your logging framework. Right? So then it adds log information to the span. Yeah.
I just wanted to add, in relation to the last question, that the way we use OpenTracing logging is to, inject the span ID into the log message, and then you are able to, from our Instana installation, we're able to view the logs for a span rather than injecting the logs into the span.
Yeah. That's awesome, actually. Because then you can. You can just not log what you don't want. And, yeah, that's another approach. Absolutely.
Sorry, since we discussed this. When you aggregate these logs, they are not part of the context, right? I guess they can just emit it and then So they're not transported with the context, with the serialized context from application to application. Right? Otherwise, you would end up in something.
Right.
really
The log. Right. So you mean in the log, right?
Yeah.
Yeah. So the log is then using that approach that you mentioned, you could take the span ID from the logs and then send to a, it's not synchronous, so you could send to another service. So you could still build the context based on that ID. Right, I mean, he can probably confirm that, but
Actually, the real question is that what kind of involvement of the backend in logging or in monitoring of each step, whether you generate a context at the very beginning with some transaction ID, then you don't actually interact with your backend, you interact only with your services, and you gather all these metrics, tags, whatever, till the end of your line, and only in the end it's all get dumped into the backend, and then you analyze it and do some display. Or actually every call of between your services involves the calls to this backend to register next step in the life of one span. How it happens.
So I'm not quite sure I got the whole context, but so you're saying that instead of each service reporting its own spans to the server, it would just get the whole trace and then the initial one sends data to the server. Is that it?
I'm actually asking how is it.
Okay. Yeah. So what it does is each service is responsible for collecting its data and sending to the tracer. And telling the tracer about it. And the tracer then decides what to do with that data and how to do it. So there might be a tracer out there that works like I said, so that propagates permission downstream, and then the problem is with microservices, that one might fail, right? So then you lose the whole trace. The usual approach is each one of the machines send data to the server. In Jaeger, there is a service running locally, the Jaeger agent. So your application would send data via UDP to a local port, and that agent would send data to the backend. For Hardware APM, it's a thread, like for Java, it's a thread that runs in the background. So the one that collects data about your application just sends data to this thread and says, this happened, and then that background process then sends to the server. And the server is then responsible for building the whole trace.
So everybody sends its own spans.
Yeah.
The server aggregates.
Yeah, because that allows you to have failures, right? So each one may fail independently. You don't want something to fail and affect other things.
How would you defend the performance of your service?
I was waiting for that question. Yes.
I actually asked about the performance because how much overhead does it add?
Yeah. So I had a hidden slide for that question. So the real answer is it's not a question for OpenTracing. It's a question for the implementations. OpenTracing itself is only the API. So the no-op tracer will add pretty much nothing, code, but it will do nothing as well, right? So it's but I mean, if it is, so the rule there is in the community is it is acceptable up to 15% of overhead, whatever 15 means to you. So it might be CPU, it might be memory, it might be something else, but there will be an overhead. Now that's why also big companies don't trace everything that comes in. There are some techniques to do adaptive sampling. So at some point I want to know about all the requests. If I'm having an outage, I might increase the tracing for one specific service. I want to decrease if everything's fine. So there are approaches for that.
One more thing, sorry. So you would say it plays in the same league like commercial solutions like Dynamics, Dynatrace, or Juraci or something?
So most of the commercial solutions for tracing, they either already have a OpenTracing library, or they're planning to. So I think you mentioned Instana. Instana has also an OpenTracing tracer, and it's awesome, by the way. The UI is really great. I've heard that some other vendors also, big vendors, looking to support them. So yes, plays on it. So the thing is, OpenTracing was born out of the necessity of big companies. And they had problems like how do they make sure that their JavaScript is returning data similar to their Java application. Okay? And they created this spec so that they could implement themselves, and this is now a industry-wide spec.
Maybe it also works like this. So we are running at the moment Sleuth, if you know it.
What is that?
Sleuth from Spring Cloud.
Oh yes, okay.
Yeah, it's also tracing implementation, and it's actually producing to Kafka or via HTTP to Zipkin. And so my question is, what benefit do I have from this open tracing? Can I exchange a backend like Zipkin with something else, or is it? What I didn't understand is what is this kind of standard? So can I exchange some products, some backends?
No. Well, you can change the tracer implementation that you are using, but you cannot make the Hopper API tracer send data to Lightstep or to Instana, for instance. So you cannot do that. So in that part, it's not better than Sleuth, but I mean the advantage that I see against Sleuth is that that's a Spring specification or a Spring project, right? So it's open source, but it's still proprietary from Spring. So there is no one implementation. Now for OpenTracing, there are several implementations. You could implement your own tracer that sends data to two different backends. Right? So you could have one tracer that sends data to Jaeger for trace view, and then data also to Hopper APM for business use. So that's the advantage that I see. Now, if you want to change the backend, if you have one concrete implementation, then you want to change. You want to use another one, you have to change your code. So, or at least the configuration. Is that clear, or does that answer the question?
It's clear, but it doesn't make me happy.
Okay. Okay. So yeah, what I can offer you is that OpenTracing provides at least an API that you can accept that it's implemented by different vendors. Right? With Sleuth, you just accept that it's done by Spring, and you trust them to keep the project for so long and so on. That's the main difference, I would say.
But there's like no standardization on the format or stuff like how the trace information.
Well, so that's something that comes a lot in the community, and it's not because we never thought about it. It's more because if we specify a wired format for the communication between the client and the server, or if we specify what is the storage format for the traces, then we're telling the backends this is how you should do it, and then you kind of block other people from doing different things. So the logging part, for instance, I mean, how do you specify the wire transport for the logs? Right? You cannot do that. I mean, if you think differently, then join the community and let's discuss that. I mean, that's a topic that's very recurrent. So I think eventually, in my personal opinion, eventually there will be a specification for some endpoints, basic endpoints, to allow this interoperability. But I wouldn't count on it.
I think we're running out of questions. Thank you very much for the presentation.
Thank you.